Welcome back, Calculus. Our objective for today is going to be to use the chain rule to find derivatives of compositions. I'm going to force a pause on your screen. You know what to do from here. All right, I'm going to force another pause on your screen. I'd like for you to copy the table, and then we'll fill in a couple together, and then I'll ask you to do the rest on your own. So let me move this over here, so hopefully you can see it. So go ahead and copy the table, and then we'll come back and do a few together. Okay, we are back. So we want to find an outer function f and an inner function g of x where the composition, which remember is one function inside another function, it's not a function times another, would get me back to h of x here. Okay, so for example, my outer function for this could be square root of x, and my inner could be 4x squared minus 7, because when I put g of x and in place of x there, I would get back to h of x, what I have in the first column, okay? By no means is that the only way to do it. I could have done, for example, square root of x minus 7, and let g of x be 4x squared. That would have worked as well, but maybe somewhat more obscure. So we're kind of going for the most obvious inside and outside functions, if you will. Okay, so let's try the next one. The outside function would be x to the 4th, and the inner would be 9x cubed minus 8, right? So I'm taking this function and putting it in for x here, okay? I'm going to force pause on your screen. You try the next three on your own. All right, so here are answers. You can check yourself. I really do want to highlight this row here. We deal with e to the x a lot, and oftentimes our exponent is something other than x, and I just need you to kind of make that mental note of your inside function in this case is actually what's in your exponent, okay? So that is my inside function, and my outside function's e to the x. So we're going to be deriving these kinds of functions today where you've got one function inside another, and that's really going to be our last rule. So we've got product and quotient rule, and now we're adding chain rule to kind of to our arsenal here. So what I'd like for you to do is, can you copy that function, y equals quantity 3x squared plus x squared, okay? And what would you say is the outer function in this case? So my outer function's x squared, and my inner function, what am I squaring? Well, I'm squaring the quantity 3x squared plus x, okay? And we're going to try to figure out the derivative here. So here is kind of where I've gone with it. If I just had x squared, I would just fly and subtract, correct? So what I've done here is I have flown the 2 to the front, and I've subtracted. Okay, so that is going to be the derivative of the outside, but then I've got a question mark here, okay? So we are actually we need something to account for the derivative of the inside piece as well. So let's see if we can use a rule we do know to figure out what the derivative is and try to spot a pattern, okay? So how can I rewrite this? Well, I can rewrite this as a product, right? This is 3x squared plus x times 3x squared plus x, okay? And again, my goal is, can I get it into this form? So here's what we're going to do. I'm going to have first function in blue, second function in orange. So for y prime, I need product rule now, right? So derive the first, we're going to get 6x plus 1. Now hold the second. So 3x squared plus x plus, for product rule. Now hold the first, 3x squared plus x, and derive the second, which will be 6x plus 1. Okay, so do we agree that these two terms, if you will, made by product rule, this one and this one, are the same? Good, so we've got two of those, right? We've got 2, and I'm going to write 3x squared plus x, and then times 6x plus 1. Well, how does this compare with our prediction over here. What was the question mark? Well, the question mark is this piece here. And where does that piece come from? That's the derivative of the inside portion, right? So what we got was we took the derivative of the outer portion. So that would be fly this 2. Then we held the inside portion the same, right? New exponent of 1, fly and subtract. Then we multiplied by, what was this again? That was the derivative of the inside, okay? So let's see if we can make that pattern continue. All right, can you copy this function now? Y equals quantity 3x squared minus 4x all to the negative 1. My outer function in this case is x to the negative 1, and if I take that derivative, it's negative 1 x to the negative 2, correct? My inner function is everything in parentheses, 3x squared minus 4x, okay? So we're going to see if our pattern works again. So if I take the derivative of the outer piece and hold the inner, then I would get that part that I just put in brackets. Now, according to our prediction from last time, this question mark should be the derivative of the inner function. I dropped an x here, which the derivative of this is 6x minus 4. All right, so that's our prediction. Let's see if we can get there. Again, we're going to need to rewrite this in a format where we know how to take the derivative. So if I have an exponent of negative 1, I can rewrite this as 1 over 3x squared minus 4x and use quotient rule now to find its derivative, okay? So y prime, derive the numerator, be careful, because that's 0. Hold the denominator, minus, for quotient rule, hold the numerator, derive the denominator, we get 6x minus 4. Then it's going to be all over the original denominator squared. Okay, so what happens here? Well, 0 times anything is 0. That goes away. I am going to take this negative 1 and bring that to the front so that it matches what my prediction is. Then this piece, if I have a power of 2 in the denominator, I can bring that to the numerator and just change the power to a negative 2. And then I still have this guy, right? 6x minus 4, which is exactly what we predicted, okay? So let's go piece by piece here. This is the derivative of the outer function, right? I flew the negative 1, and then I dropped my power by 1, keeping the inside function still, okay? So I deal with the outer function first, then I multiply by the derivative of the inner function, which was that guy. All right, so this is possibly our most important rule all semester, chain rule. This is how I differentiate compositions, function compositions. So if I've got a function inside another function. So I'm going to force pause on your screen, copy what I have, and then we will write it together. Okay, so if I have h is f of g of x, so g is the inner function, what I'm going to do is take the derivative of the outer piece first, holding the inner piece exactly as is. Then we're going to multiply by the derivative of the inside function. Okay, so make sure you've got that written down. So if you want to see this in Leibniz notation as well, you do not need to write this down. It's not as common, but it's sort of nice to see if you have that your outer function is f of u, make sure I pronounce the of there well, and your inside function u is g of x, then dy dx, the derivative of y with respect to x, would be the derivative of the outer function with respect to the inner times the derivative of the inner with respect to x. And you can see that the algebra there works nicely, right? Because you kind of see that cancellation, you get dy dx there as well. So this is one of my favorite comics done the year I graduated high school, no less, by Courtney Gibbons. This is called How I Learned the Chain Rule. She says, differentiate the mother, hold the baby inside. So the derivative of the outer, holding the inner, and then differentiate the baby. Okay, so that's often how I will talk about these functions is the mom and the baby, because inner and outer is not really necessarily mathematical talk either. The nice thing about mom and baby is that coming up, then we can expand the generations to grandma, mom, and baby, etc. Okay, it's time to practice. I'm going to force a pause on your screen. Please copy what I have, and then we will do these together. Okay, we're back. So, notice that all of these require a chain rule. In the case for all of these, the inside function is always 3x squared minus 2x minus 7. That's the case for all of them. The only thing I've changed is the outer function. Okay, so let's try. Here, I'm going to have y prime equals, so deal with the outer function first. What's the outer function? It's x squared. So if I were to derive x squared, it would just be 2x, right? So it's going to be 2, but instead of x, I got to hold the baby inside, okay? 3x squared minus 2x minus 7. I technically have drop my power, so that's a power of 1. So that's f prime of g of x times then g prime of x, derivative of the inner, will be the derivative of this piece, which is 6x minus 2. Okay, and that's it. That's how I want you to write it. Okay, that next one, let's rewrite this. We could do quotient rule, right? Or we could rewrite this as 3, let me get it down here. We can rewrite that as 3x squared minus 2x minus 7 all to the negative 1. So if I want to find y prime, I'm going to take the derivative of the outer, and the derivative of the outer is this exponent of negative 1. So I need to fly, hold the baby inside, and then drop my power. So my new power is what? Negative 2. Am I done? Nope. Now I need to times by the derivative of the baby, which again is going to be 6x minus 2. The inside was that. All right, that next one, we need to rewrite that as some kind of function I can differentiate. So we can rewrite that as a power of 1/2. That's just a rewrite now, so that was the algebra. Now let's do the calculus. So my outer is x to the 1/2, so I'm going to fly the 1/2, hold the baby inside. My new power is negative 1/2. Okay, so that's the derivative of the outer holding the inner, fly and subtract, times the derivative of the inner. Okay. Anything I need to rewrite for the next one? Nothing I need to rewrite there, so we can go straight to the derivative. What is the outer? The outer function is technically 5 sine. That 5 is going to come with us. What's the derivative of sine? Derivative of sine is cosine, so that's the derivative of the outer, hold the inner, then times the derivative of the inner. So that's going to be 6x minus 2 again. The only thing I would ask that you do here is put your trig terms at the end. So let's bring that 6x minus 2 forward. That way it's not so ambiguous as to what we're taking cosine of, or where are we multiplying that 6x. It's minus 2, it's a little more clear. Okay, that next one, what is your outer function? 8 ln of x, right? That 8 comes with us. What's the derivative of ln of x? It's 1 over x. So instead of 1 over x, we're just going to have the 8. Okay. Instead of 1 over x, I'll have 1 over, and I have to hold the baby where I would normally have the x. So I'm going to hold that 3x squared minus 2x minus 7, and then times, again, the derivative of the baby, so 6x minus 2. You may see this written as 8 times 6x minus 2 in the numerator, and then that 3x squared minus 2x minus 7 in the denominator. So if you see that this first way we had it was not wrong, but if you see that, just don't let that throw you off. All right, that last one. What is the outer function? The outer function here, remember, is e to the x, okay? And the inner function is still that 3x squared minus 2x minus 7. So I'm going to take the derivative of the outer, which is just itself, holding the baby in its place, then times the derivative of the inner. And again, I'm going to bring that to the front, and trig and exponentials, general mathematical notation, we put those at the end. Okay, can you copy these two in your notes, and we're going to talk about the difference and find the derivative of both. Okay, we're back. So the first one, we've got sine of, that means x squared, okay? So in this case, what's your outer, sine or x squared? In this case, your outer is sine, but in this case, please, when you see these exponents, the first thing I want you to do is do a rewrite, and rewrite this as sine of x quantity squared, okay? So in this one, what's the inside? Sine, or let's say, what's the outside? Sine of x or x squared? That would be the squared, x squared in this case. So we've basically flip-flopped inner and outer here. So let's try y prime here, derivative of the outer, so derivative of sine is cosine, hold the baby, then times the derivative of the baby, which is 2x, okay? And again, just please put those trig terms at the end. Now for the other one, we need to take care of the outer first, so fly the 2, hold the inside, you can drop your power, then times the derivative of sine of x, which is cosine of x. So that's my final answer there. All right, our last example, I would like for you to bring this to class. H of x is f of g of x, and I've given you h prime of 1, f prime of 3, f of 1, g of 1, and g prime of 3. And you will not need all of these, but you will need some. Go ahead and apply chain rule, the one I had you write down. Just plug in 1 for x and see if you can get this and bring it to class when we see each other. All right, I'll see you all next time.